the previous class, we learned about acceleration due to gravity, objects falling, and the definition of free fall. So we learned that free fall is when objects are falling and nothing is stopping them. So they feel no air resistance. They are only being acted upon by gravity, so they fall with an acceleration of g that is equal to 9.8 meters per second squared. So what we're going to do today is learn how to describe this type of motion with acceleration due to gravity and no air resistance using equations. So these equations are 4 equations that are used in all of motion and are called equations of motion or kinematic equations. We're going to look at them in more detail next class, but today I just wanted to introduce them to you by doing the specific case in which the acceleration is the acceleration due to gravity. There's no air resistance, so we can cancel some terms out and have a simplified version of these equations. We're going to start with 3 statements that are going to determine what we're going to do and when these equations work. So the first one is that because we're talking about free fall, the acceleration is always 9.8. So that's one of the things that we need to have always in these examples. Acceleration is called g, and it's equal to 9.8 meters per second squared. That is one thing. Now, because it's free fall, we can also say there is no air resistance. No air resistance. So we can always, in every example that we're going to solve, we can ignore air resistance completely. We won't talk about it again in exercises. And the third thing is that usually objects, when they are dropped from really high up, at some point they reach a terminal velocity and they stop accelerating, so their acceleration isn't 9.8 meters per second squared anymore. That's not going to happen here. So we're not talking about terminal velocity either. No terminal velocity. So basically, these 2 last things just mean that the acceleration will always be 9.8 meters per second squared, constant. It will never decrease, never increase, nothing. 9.8 meters per second squared, downwards, of course. We'll start with 3 basic equations and we will apply them to 2 examples of free fall or acceleration due to gravity. So the equations are the following. We have this equation. It doesn't matter where they came from. Let me write them down and then I'll explain the meanings of all the variables. So there's this one, and there's this one. Okay, so these are our 3 basic equations, and the meanings of these variables are the following. So you might notice there's a y. Y is the height. Yeah, it also means the distance in the y-axis. So it's called, okay, so vertical distance. It's called y because when we draw a graph in math, we always have our y-axis and our x-axis, right? So when we're talking about distance that is horizontal, we call it x. Right now we're talking about free fall, things that are falling. Every movement is in the y direction, so we call the distance y. So it can be called the height or the vertical distance. That's y. Then we have g, we already know what it is. It's our acceleration and it's 9.8 meters per second squared always. We have v sub 0, VO, I call it VO, and this is the initial velocity. So our objects will have an initial and a final velocity. This is the initial velocity. Initial velocity. Then we have a V that does not have an O below it. That is the final velocity. So V is final velocity. And finally, we have a t, which is time. So we need to remember that units are very important. So the units for height is meters. The unit for g is meters per second squared. For speed or velocity is meters per second. Final velocity is also a velocity, so it's also meters per second. And time is in seconds. So if we have a unit, if we have a value that is in a different unit, we need to convert it to these units: meters, seconds, and meters per second, or meters per second squared. Okay, so those are the names of the variables. So for example, in this equation, what we're saying is the height of an object that is in free fall is given by the multiplication of its initial speed times the time minus 1/2 times 9.8 times the time squared. These equations look a little hard, so that's why we're going to divide them into two specific situations and simplify them a little bit. So which are our two specific situations? One of them is objects that we drop. So I'm going to write that here. Dropping objects. So what dropping objects means is that you have an object, you put it up here, and you let go without giving it an initial push. So its initial velocity will be 0 because you just let go, and the object will start accelerating because of gravity, but not because you gave it an initial speed. So what we have here is that the initial speed is 0. So in our equations, we can cancel out the initial speed. This process that I'm going to do isn't really important that you understand what I'm doing. It's okay if you don't. What's important is that you know at the end how to use the equations that we're going to get to. So v0 equals 0, I cancel every term that has a v0, so I'm left with the first equation, y equals, this cancels out, so I'm going to put it like this. So this is one of our equations. So the height of the object, how far down it goes, is going to be equal to 1/2 times g, which is 9.8, times the time squared. Now in this one, we cancel out the v0. V will be equal to negative g times t. Okay, I forgot the negative here. So the final speed of the object will be equal to negative 9.8 times the time. And the third one, that part is gone, so we have v equals v squared equals negative 2 times g times the height. The height is usually given as negative, so this negative will cancel out. So I'm going to write it without the negative, so that you put here how much the object is falling, has dropped, and it'll give you a positive answer. Because if you put a negative inside of a square root, it's going to give you a mistake. The calculator won't allow it. So these are the three equations that we can use for dropping objects. Notice that each one of the equations has two variables. So this one has height and time. This one has final velocity and time. And this one has final velocity and distance. And all of them have g, 9.8, but because it's a number, it's not a variable. So in each exercise that you're going to do in the worksheet, I'm going to give you one variable and ask you for another one. So for example, I could give you time and ask you for a height. So you have to look for one of the three equations that has time and height. So you're always going to use just one equation at a time. And you have to look and choose depending on what I give you and what I'm asking you for. So we'll do an example in a second. Those are the three equations for dropping objects. Now there's a second type of example of these problems. The second example is throwing an object upwards. So throwing upwards. So in dropping objects, the object was up and we let go. In throwing upwards, the object is down, we throw it, we give it an initial speed that is not 0, so that it accelerates upwards, it reaches a maximum height, and then it starts falling because gravity is always trying to push it down. So what we're going to have is that at the maximum height, the object will have a speed of 0 because it will go up with a speed that I gave it, decelerate until it gets to the top, and when it gets to the top, it stops for a millisecond, and then it starts falling in the other direction, downwards. So at the top, the speed is 0. So what we do with this option is that we say that the speed is equal to 0. and we're going to have a maximum height at that moment. So I'm not going to use this equation because nothing cancels out because there's no v in this equation. There's only a v0 or vo. So we're only going to focus on these two equations. Let's see, so if v0 is 0, we're going to have 0 equals v0 minus gt. And if I pass the minus gt to the other side, or the v0 to the other side, the negative cancels out, so we're going to get v0 equals gt. And for this one, we have 0 squared, which is 0, equals v0 squared minus 2gy. We do the same thing, pass it to the other side, and we get v0 squared equals 2gy. So these are our two equations for throwing things upwards. So again, this equation has two variables, initial speed and time. This one has initial speed and height. So if I give you a problem that asks for one of them and gives you the other one, you have to choose which equation works for you. So basically, when I give you an exercise, the first thing you have to do is identify if it's a dropping object case or a throwing an object upwards case. Once you identify that, you have your set of equations that you can use, either these three or these two. So we care about these two and these three, right? And then you need to look in the problem and see what variable I'm giving you and which one I'm asking you for. And you need to choose the equation that has those two variables and use it to solve for the one that I'm asking you for. So let's do an example. I drop an object from a height of 2 meters. What time does it take to reach the ground? So drop from 2 meters, time to reach the ground. Right? So is it drop or throwing upwards? It's dropped. It says the word drop. So we're going to use one of these three equations. And now the question gives me 2 meters, which is the height. So we have y, and it asks for a time. So we're looking for a time. We have y, and y is 2 meters. And we're looking for time. So this equation has y and t. Notice that it's the only one that has y and t. This one has v and t, and this one has v and y. So the only equation we can use is this first one. So we write it down, y equals -1/2 g t squared. You know what, I'm going to ignore the negative because I think it makes things more confusing. So let's just leave it as positive. So y is 2 meters, so we put the 2 in the y. 1/2, the g is 9.8, so we can multiply by 9.8, and t squared. So what we need to do here is solve for t. We will first pass this 2 to multiply, then divide by this 9.8, so we're going to get 2 times 2 over 9.8 equals t squared. And to solve for t, we need to take the square root on both sides. So we're going to get that t equals square root of 2.2 over 9.8. So it's important that you guys remember how to solve equations so that you can solve for the variable that I'm asking you in the question. So this is how you would solve this problem. I'm going to erase it and now I'm going to do an example of the other one. So I throw an object and it reaches a height of 3 meters. What speed did I throw it at? Right? So this is an example of throwing an object upwards. So it's not dropping anymore, it's one of these. So we're going to have to use one of these two equations. Now, what do we have and what are we given? It reaches 3 meters. That's a height because it's in meters. So we have y, it's 3 meters. And what speed did I throw it with? We're being asked for the initial speed. The initial speed, right? That's what we need to look for. So we need to find one of the two equations has to have y and VO. So the first one has VO, but it has t. So we can't use that one. That one is not going to work. So we look at the second one. It has VO and it has y, exactly what we needed. So that's the equation that we're going to use. So we chose our equation, VO squared equals 2GY, and we plug what we know, which is y, into the equation. So we have VCO squared equals 2, G is 9.8, and y is 3. So on this side, we have 2 times 3 times 9.8, right? So that is going to give us 490, I think, 490. So that is VO squared. And again, just like in the previous question, to solve for V0, we need to take the square root on both sides. So the squared and the square root cancel, and we end up with VO. So this is what we need to put in our calculator to find the initial speed. And that's it. This is going to give us the speed that I threw the object at. So basically that's the whole process. You decide if it's a dropping object or throwing an object upwards, and then you choose an equation based on what you're given and what you're being asked for, plug in the variables and solve for the variable that you're looking for. I'm going to help you out a little bit. So right now I'm going to solve for the variables so that you don't have to do it in case you have trouble with that. But it's important that if you know you have trouble with solving equations, you practice. So for example, here we have y and t squared. What if we want to put t alone? So I would multiply by 2 here and divide by g. So it's 2y over g. This is t squared. So t is square root of 2y over g. So this is the other version of this one. Here, if we wanted to solve for t, it's only dividing by g. So we get t equals b over g. And in this one, if we wanted to solve for y, it's divide by 2g. So we get b squared over 2g equals y. So this is the second form of these same equations. So basically, if I give you t and ask you for y, you use this one. But if I give you the opposite, I give you y and ask you for t, you can use this one. And here we can do the same thing. So we have VO and t. If I wanted to solve for t, I divide by g. So it's VO over g. And here, if we wanted to solve for y, I divide by 2g. So it's VO squared over 2g. So these are the opposites of these. So you can either solve them yourselves if you prefer and you understand using these three and those two, or if you don't know how to solve, I solved them here for you so that you can use these 6 or these 4. And that's it.